start recording. And okay. Bubble. Okay, so I'm sharing my screen now, and let's see. There are 12 people. 12 people currently in the Collaborate. But don't forget to sign into the discussion board, right? Today's forum. I'm sure, I guess, the only thing you can see is this one. How many people are there? There are like 12 people. There are 12 here and 12 here as matching number of people. Now, this is a little, I'm a little, puzzled because actually on the roster, there are 25 people, and that means, more than half are not attending. The official roster, as of, I guess, as of yesterday, the official roster, I don't know, it is 23 as of yesterday, but let me, okay, so that would be 24, right? 24. And then, there are people that never attended yesterday. Okay. I don't know. So if I have only, now it's 12 people, right? If I have 12, that's exactly half the number of the people officially on the roster. So anyway, I hope, whatever is keeping them, I hope they'll be joining the class shortly. And let's move on to, so what we did yesterday, I believe. Okay. Let me put this. So this is where we were yesterday. I can't find my mouse. Okay. I might have to switch to another computer because I'm currently using dual monitor setting, and on this dual monitor, so I'm using a like a 27-inch screen, and there's no, it's not a touch screen, so I cannot, if it is not touch screen, well, let's see. Even if it is not touch screen, at least, I don't have to write anything on it. If I don't write anything on it, that's fine. We can still continue with this. And if I have to write something on the screen, directly on the screen, then I will switch to the other computer. Alrighty. So yesterday we were talking about the so I will have to use the touch screen. So let me switch to another computer. Okay. Then I will have to I will have to stop. Okay, I'll be back shortly. I'll have to stop sharing or I'll have to close Blackboard. No. Yeah, collaborate from this computer and open it from another computer. Okay. All right, I'm back. So you can hear me fine, right? You can hear me all right, everyone?
Yes, Professor.
Okay, good. So let me share my screen again. And let me, what's the volume? Let me increase volume. Where is the volume? Hmm. All right, I guess the volume is fine. So now I have, it looks like I have 14 people. Good. I have, um, let me also quickly check again the discussion board and see if there are 14 here. There are only 13. Looks like um, uh, see, two threads are mine, so there are 13. So if you are in the Collaborate now, but not haven't signed into the discussion board, please do it ASAP because this is the only way you will be counted as present. Okay. All right. So oh, what's happening? I'm opening almost. Okay. So we were talking about, yesterday we were talking about why we can't use why we can't use simple average in a situation where we have a growth effect going on. Uh, through time, right? Or compounding effect. Also, let me open this so I can write on it. Okay. There's also, I said, oh, what's happening? Okay. Simple average versus geometric average. Simple average is called also arithmetic average, right? Arithmetic average. And the difference, I'm not going to go over this again, but geometric average and simple average have basically they are facing different data set. What geometric average is used is for what they call time series data. Time series, or it's also called longitudinal data. Whereas simple average is used for cross-sectional data. Cross-sectional data or latitudinal data. Latitudinal. Now think about it. What does all this mean? Latitude. So latitude and longitude, we already from the map. Longitude is basically longitude. Latitude is from left to right or east to west. Longitude north south. So what this means is times, also called time series. Also is called dynamic. Dynamic data, or and as opposed to that, cross-sectional data or latitudinal data are static. So in other words, it all has to do with time. So for some, let me also synchronic, diachronic. There are many words to synchronic, diachronic. One good example is, suppose I want to take the average of the height of the people in this class. Okay, so there are officially 24 people in this class, but let's say there are like 14 people now, currently 14 people in this class. So if I want to take the average height, then what do I have to do? I will have to take the measure of each individual's height, right? And then I will have to sum it up and divide it by 14. Isn't that right? And that's what you understand as average. But in this example, in this exercise, there is no time dimension, right? The time is basically I'm using your height data from a single point in time So the time is static, a static time, right? In other words, your height data was collected all at the same point. However, if I pick a single person, and let's say one of you, let's say who, Eric. Let's say Eric, because Eric, I'm not looking at the, currently looking at the list. I'm not looking at the blackboard, so I don't know who's there. But remember the name that I can remember and that comes to me first is Eric. Let's say I pick Eric, and let's say Eric is 2 years old now, and I want to, and I measure, I want to, I observe Eric's growth over time. So Eric is 2 now, but I measure his height until he's 22. Okay, so then I will collect 20 years worth of data. Isn't that right? And so from 2 years to 22 years, I mean, the height would obviously there will be a huge variation in the data. But if I collect the Eric's height every year, if I measure for 20 years, then what is the purpose? Obviously, I want to know the growth rate. Of course, every year the growth rate will be different. I mean, during the teenage years, during the puberty, you will shoot up like, you shoot up like 2 inches, 3 inches a year. But once you are mature, you don't, once your growth has stopped, I mean, after like, 25, 26, hardly you don't grow. Not even by the age of 20, I don't know. You may grow, but hardly even, hardly even, 1/20th of an inch, right? And then, stop growing at some point. So if I want to, if that is the case, then if I want to take the average, that average is not the average like, you cannot add up all those numbers and just divide it by 20, right? Because there's a, compounding effect or acceleration effect, right? Of course, the growth accelerates during the teenage and slows down after 20 something, or around 20, and completely comes to stop, or completely comes to a stop by the age of probably 24. Some people may grow even after that, but so that is what is meant by time series, right? If I collect Eric's growth data every year, that forms a time series. And it's called longitudinal data. Dynamic means, change, right? The word dynamic to some people, it means, wow, very, active motion. But think about it, motion comes only from passage of time. If time stands still, there's no motion. You understand, right? So dynamic, dynamism, dynamic, there is an inevitably time dimension to that. If there's no time, everything is static. If time stops, there is nothing dynamic. Everything is static. And through time, that's called, diachronic, right? So, yes, geometric average and simple average are different. They are used in different contexts. simple average is what you have known as average so far, all this time. Now, how do I move to the next page? This is the this is the problem with this app. Okay, I don't know how to move to the what should I do? Oh, I see. New drawing. Okay, so but then other than simple average and simple versus geometric average, there is also weighted average. Weighted average, right? What is weighted average? Now, in simple average, right? Everyone's height. If I take I want the average of average height of the people in this class. Everyone's height is given the same weight. I mean, there's no reason why somebody's particular, person's height should be given any different weight. But sometimes the weight, the data will carry different weight. A very good example is your GPA. GPA is a good example of weighted average. And I'm sure I have that example. Let me. And you have no problem hearing me, right?
Some people
if you have any problem, yeah.
No, I don't have any problem.
Okay, great. Because if you had a hard time hearing me, then obviously someone had already raised a question. Okay, so let me open. ROI, I don't have it. Oh, here. No. Where did I? I thought I already downloaded it. This is okay. Here, let's go to course material. Okay. So you can also open this file, right? You can also open this file. So let's think about your GPA. Suppose you took four courses last semester: English, math. AFL is African Latino studies or something like it. So ethnic studies, art, maybe art 101 or what. Now, so four courses, four classes, and from those classes you got B plus B, A minus A. And so B plus is 3.5, B is 3.2, A 3.7, A 4. So you might think, oh, my GPA must be 3.6 because, it's, average of that. But that average that you just calculated, if you got 3.6, you took simple average. Simple average is what? This means X, you understand what this is, you're summing up all the X data points, right? Where I runs from 1 through n. So if there are n data points, and in our example, n is 4 because there are 4 data points, and x is the data value, right? So x1 would be 3.5, x2 would be 3.2, x3 3.7, x4 is 4. So you sum all of them, divide it by 4, and then it's going to be 3.6. So you might say, oh, so my GPA is 3.6. But that is wrong. Why? You can't take the simple average of your, GPA, why? Because all these classes have different weights, right? And the weights are reflected in the credits they carry. And most college classes carry 3 credits. 3 credits means they meet 3 hours a week. Of course, this course also has 3 credits. But some courses have 4 credits, like math. Math is always 4 credit. Why? And that means math classes meet 4 hours a week. So you might wonder, oh, so it's just the number of hours. But why in math class there's more number of hours? I mean, why do you have to meet 4 hours a week? That means math is that much more difficult and more important, right? You're meeting 4 hours a week, 1 hour more than any other course, any other class, because math is that important, and it takes more time. It takes more time to comprehend it, right? Now, so, and then it's hard to find 2 credit or 1 credit courses these days, but still there are 2 credit courses, and you can find it in ethnic studies or in art and music. And think about it. Honestly, the reason that there is a one credit course in art or in music, it's rare these days, but there used to be one. And that means they meet just once 1 hour a week. And the reasoning behind it, a good explanation is, obviously it doesn't take as much brain power, right? It doesn't torture you. Art and music doesn't torture you like math, right? And basically, what's the point of art class? I mean, it's not about, using torturing your brain, or, thinking hard to solve a problem, or thinking hard to to reason out, or to use deductive reasoning or any logical thinking to come to any conclusion. Art is there to enjoy. I mean, just enjoy. Some artists, of course, agonize over their work, But most of the times it's it's to enjoy. I mean, of course, some artists really pour themselves into it. So when you calculate GPA, you cannot simply add them up and divide it by the number of courses. You have to weight that importance. So how do you weight that importance? Well, to GPA, you multiply GPA by their credits, right? So so English, the weighted grade points will be 10.5, right? 3 times 3.5. Math, 12.8. Ethnic studies, 7.4. So this way, the sum of all those weighted points is 34.7. And then you divide it by the sum of those credits. You divide it by sum of those credits, right? Sum of those credits is 10. So you divide it by that, then you come to 3.47. Hence, that's the weighted average. Okay? Now, so the weighted average is, it has a lot of, application. It's actually in finance when you are allocating. Finance is all about, portfolio allocation. Why? Because you cannot, you cannot maximize return while minimizing the risk if you just without portfolio. The whole purpose of constructing a portfolio is to maximize the efficiency of the portfolio, efficiency of your asset holdings. Therefore, it is all weight, right? There's the portfolio. When we say the ideal construction of portfolio is, I mean, of course, first of all, there's a complete portfolio. Complete. I would rather not. Okay. Portfolio. P stands for portfolio. PC, complete portfolio. Complete portfolio consists of risky portfolio, a portfolio that consists of risky assets plus risk-free assets. Okay, or riskless asset. That's complete portfolio. But then, so if you have $1 million, $1 million, how would you allocate $1 million into the risky portfolio? How much of that $1 million and how much of that will you put into the risk-free assets? Now, so obviously, there's going to be some weight. And how do you, so will I put 60%? That's called weight. Weight in the risky portfolio. And there's weight in the risk-free assets. So how should I determine that weight? It's not arbitrary. I mean, you don't do it arbitrarily. The weight will be determined by a meticulous rule, because the weight, depending on the weight, the portfolio, the efficiency of the portfolio, which is measured by what they call Sharpe ratio. Sharpe ratio can go up, or Sharpe ratio can go down. Of course, higher Sharpe ratio is better than lower Sharpe ratio. So, and then in the risky portfolio, again, risky portfolio consists of stocks, portfolio of stocks, and portfolio of bond. I'll just call okay. And then, of course, even there should be weight. What kind of, so if the weight between risky portfolio and risk-free assets was 70% to 30%, then this 70% will again break into, okay, 60% in stock and 40% in bond, or but these weights will, it's not random, it's not arbitrarily picked. We have very meticulous rule, mathematical rule, that will improve or maximize the Sharpe ratio. And so weighted average is a very important tool in finance. Okay, so that being said, we took too much time. We spent too much time on the definitions. So we'll actually do something. So here, we talked about this yesterday. There are two scenarios. I mean, if you buy a house, you can use it in one of the two ways. One, just use it as your home, right? Two, you can use it as an investment property. In other words, you can use it as a rental building, right? And in scenario one, there is no additional income, but in scenario two, there will be additional income because there's rent. Rent comes in. So in scenario one, the only source of cash flow will be capital gains when you sell it, right? In scenario one, we talked about that. But in scenario two, these annual rents are basically additional income or cash flow. So if you want to find the holding period return without cash flow, in other words, under scenario one, not a difficult thing, we found that. And then if this is capital gains divided by the initial investment. And then if you want to you will include the, in scenario two, you will include the additional income, capital gains and additional income divided by the, but then this is from 11-year holding period. And there's no way of directly comparing it with other investments that have different holding period. So we need to equalize the holding period. How do we equalize the holding period? Annualize. On annualized basis, you can compare anything. So before annualizing it, so what I did here is these are annual growth rates. Annual growth rates in house values. We did that yesterday, so I'm not. And then you might think, oh, so I take the average of these. Simple average? No. Arithmetic. If you take the arithmetic average, right? This is what it is, and it's incorrect. It's overstating, right? It's over because it's overstating true annual average because it ignores that compounding effect, right? It ignores compounding effect because each year's growth is built upon the previous years, right? So we have to use geometric average. And how do you calculate geometric average? I'll give you the formula straightforward. But at this point, there's no time to explain to you how that formula was derived. You'll just have to. There will be a time later. I will explain it later. When we get to that part, right? When we get to that topic, I will explain how that formula is derived. But at this point, there's no time for that. So I will just, give that to you just right away, straightforward, right? So the formula for geometric average is pt plus n over pt over raised to 1 over n minus 1. What does that, so what is pt plus n? Now remember, pt is the price at the beginning, right? Price at the beginning of our timeline, or price at the beginning of our the first data, our first price data in our holding period. So our holding period was 11 years, from 2005, end of 2005 to end of 2016. So this is our PT, right? Our first data point, that's our PT. And this is our PT plus 11, isn't that right? So in our example, n is 11. This is our PT plus 11, PT plus n, because our holding period is 11 years. So it's the price at the end over price at the initial price, right? The price you paid, PT is the price you paid, PT plus N is the final price, the price that you sold it for. That raised to 1 over N. So N is 11 in this case, so you raise it to 1 over 11 and then minus 1. Okay, so also it is sometimes I write it this way sometimes. I don't know what this is. No. New drawing. Sometimes I write it like this. G, growth rate, right? G stands for growth rate, but also since it is G, you can think of it as geometric average, right? Future value over present value raised to 1 over nth power, right? Minus 1. Now, future value is basically it's the same thing. This is price at time t, right? And future value is then price at time t plus n, right? So if 2005 is present, right, time 0, right, price at 2005 is the present value. And then 11 years later, price at 2016, that will be the future value, right? Of course, to us, it's all in the past, but, when you have this timeline, the beginning of the time, that's, time 0, that's the time 0, right? Time 11, this is the timeline. I mean, which one would be the future? If this is the future, this is the present. If this is the present, this is the past, right? Isn't it right? If this is the present, that's the past. So then using that formula, right? Using that formula, I found the geometric average. Okay, using that formula here. You see, what is B2? B2 is the future value, right? I don't like this. The Chromebook is giving me all this. So 2 is price, right? At the end of 2016. Then B13. And then we know it is 11 years, but I want to make sure. I mean, how do you know if it is 11 years? Of course, 2016 minus 2005. Or you can count, but you know, instead of visually checking or counting, this is infallible. It's unmistakable. If you, from A2, if you subtract A13, right, that's 2016, 2005, that's going to give exactly 11. So 1 over n, and minus 1. Okay. Now it may seem it may seem a little too complicated. I mean, why so many parentheses? Parentheses are so important. Why? Because to all human eyes, it's obvious. When you write it like this, to human eyes, it's obvious. I mean, FV over PV, I mean, by putting the parentheses around it, this exponent, okay. It's obvious. This, oh, that's too big. This exponent pertains to, it's obvious, right? And then how did I find n? So it's like, writing it like raised to 1 over n minus 0, or let's say it's like t plus n minus t. Okay, and then minus 1. Now, because when you raise it to power, and if you put it into Excel, because it is written linearly, you will have to write it linearly. Okay, and this is the symbol, this is the universal machine language for raising something to power, right? It's got a name. It's called caret. Caret. It's written caret, which is actually from French, carré, meaning square. And by doing this, so in Excel, you are writing it linearly. So actually, this is not right. I mean, in Excel, you don't even write it like this. So Think about it. You write it like this in Excel, and then raise 2. Then think about it. You cannot, it's not going to be like this. It's not going to be like this. You will be doing it like this. But then without parentheses here, Excel would raise that to 1 and then divide it by divided by this. So by using parentheses, it makes a clear distinction. It gives a clear instruction or demarcation. Up to this point, it is, I mean, this whole thing is one chunk, right? Anyway, that's how I did.
Professor, can I ask you a quick question about that?
Yes. Yeah, go ahead.
Just in terms of, you mentioned the Excel. Does Excel have a pre-labeled equation? Just averages and standard deviation, etc.
Yeah. But look. You need to look. You're talking about you're talking about a pre-built function.
Yes, sir.
Look, but it is like if you use for example here you can do that, and for I used basically you can do arithmetic for average. If it is if it is arithmetic average, you can do simply but we are not come on, and then
Yes,
okay.
I understand that,
But then
do they have financial equations?
Yes, you can find. Look, but then it's like just relying on GPS. You understand? There are times you have to use. There are times that you have to use Excel's built-in functions, but if you are using, you should be able to do it yourself. In other words, if you use when you drive, if you just rely on the GPS, then your brain will lose the ability to.
I totally get that. I was just wondering if it has it. I understand I need to know, but I was just wondering if it has it.
Yeah, well, then that answers the question. I mean, instead of the point is you should be able to think and build that thinking into Excel as a mathematical algebraic model, right? That ability to think that's what's important. But also, you should be able to adjust the model according to the data format that it is or data type that it is provided, the data type that's provided, right? In other words, you can, if you use like future value, if you use future value function here, future value command here, if you use future value command here, then you are just nothing but you are just simply inputting the data. You're just entering data. There are times that you will have to you will have to tweak the model or tweak the data accordingly, right? Because the context would be different. I mean, it will take a lot of. I mean, at this point, you don't see any concrete examples, so you don't.
I understand. I totally get
It
it.
takes too much time to explain that, but the data is the input data isn't always given on a nice platter, silver platter, in a digestible, chewable format. Sometimes the question is about how many months or how many um, or monthly rates, but the data given are all annual or weekly, or I mean, if you're just used to using Excel's built-in function, then you don't know how to make adjustment to the formula or to the data. So you
I
just
understand. Sir.
mechanically and input the data, and then it just takes you to the wrong answer. It just takes you to nowhere. So that the point is, you should be able to do it. You should. This is a.
Professor, I'm an
This is
economics major. I totally get what you're saying, statistics and all
okay.
that. I get it. I just wanted to ask you that simple question. Thank you so much.
You're welcome. You're welcome. So again,
Professor, before you continue, I had a quick question.
yeah. Can you speak up? Can you speak up?
Yes, do you hear me, Professor?
Yeah, I can. I can hear you, but if you could speak up, I would appreciate it.
I had a question for the geometric average formula.
Mm-hmm.
For 1 over n, does n represent the n?
Number of years or number of periods. Okay,
Oh,
it doesn't have to be. Yeah, it doesn't have to be years. I mean, in our example, it is number of years, right? N just represents. N is a symbol for number. So n can be, in our example, our data is annual. So n is number of years. But if this is monthly data, n will be over 11 years. There will be, if we are dealing with monthly data over 11 years, there will be 120, and that's 10 years. So 132 data points, right? If it is monthly data. And then if it is, in that case, n will be 132. So in other words, it brings us back to the same, thing. If you just use a canned program, you just become a data entry personnel into the formulas that are pre-built formulas of Excel. You will be just, if you are just entering the data, then in the situations like this, if the data that we are dealing with is monthly, then n will have to be accordingly 132, not 11, right? So
okay. Thank you.
Mm-hmm. Now, next question. So now so arithmetic average is overstating the geometric average because it is, not it's not taking into account that growth effect or the compounding effect. Now, column G, let's take a look at the column G. What is column G? Column G says R. What is R? R stands for return. Then you might wonder, didn't we just get the annual returns in column F? Yes, column F is return in effect. But why is it labeled G? G stands for growth rate, right? But what is the difference? I mean, isn't growth rate the return? It's the same thing in scenario one. In scenario one, and you remember what scenario one is. Scenario one is where you buy the house and use it as your home. There's no additional income. So it's just like in scenario 1, since there's no additional income, there's no cash flow. In other words, in this formula, right? Scenario 1, you don't have this. You don't have this part, right? You don't have this. This is 0 in scenario 1. In scenario 1, you have only this, capital gains. But so growth rate is exactly the return in scenario 1. But in scenario 2, we have additional income. So then return will be annually, year by year, return will be capital gains plus additional income divided by the house value of the previous year, and then we can drag it down. Of course, the return will be greater than the growth rate, but deliberately I left these first 3 years. There's a reason why I left first 3 years with no rental income. Why? Because in the that way you didn't rent out the place in the first 3 years, and that way the return and growth rate will be exactly the same, right? Return and the growth rate will be exactly the same. But from the 4th year, return is of course greater because return has one more component. Okay, so and I've been telling you, in scenario 2 is like stocks, most stocks and coupon bonds. Because if you are buying stocks, if you hold stocks, not all the stocks pay dividends, of course, not all the stocks are paying dividends, but most stocks pay dividends. And if they are paying dividends, it's like, there's when you sell the stock, you will have capital gains, and then there will be throughout the holding period. Also, coupon bonds. Now I'm throwing out these concepts, before we get there. But if you buy bonds, there are coupon bonds and zero coupon bonds. Coupon bonds are the bonds that pay interest. Zero coupon doesn't pay any interest. So think about it. If you coupon, this is the price you pay for that coupon bond when you buy it. This is the price that you receive when you sell it. Of course, in case of bond, maturity value is always, fixed, $1,000. But and stocks, this is the price you pay for the stock, and this is the price you receive when you sell it. During that time, dividends are paid or interests are paid if it is bond. Now, scenario 1 is like zero coupon bond. Zero coupon bond doesn't pay any interest, so there will be only capital gains. Stocks that don't pay any dividends are also like scenario 1, right? So when it is dividend paying stock or coupon bond, how do you find the geometric average? We need actually to do that. We will need to use geomean command. We cannot do it this way because this formula is only for the case where this formula works only for growth rate. In other words, scenario 1. For scenario 2, we will have to use the geomean command. I mean, it's basically basically the same thing, but it's a little so the geomean command would require, so 1 plus r is what? It's basically, you know, we'll do 1 plus r. It's the equal sign. I forgot to put equal sign. I'm sorry. One plus r. It's the gross growth rate. Think about it. This column G is the net return or net growth rate, whereas 1 plus R, 1 plus G is the gross growth rate or gross return. I'm going to talk about that a little later. Okay. And then I drag it down. Okay. Here, what I have here is the product. In other words, I multiplied all of them, right? Through and through. That's the product. And just for the just for the fun of it, let's do it for 1 plus G as well. And down here, I have already, you know, entered product. 3.333. You see some similarity here. You know, what is this? The holding period return in scenario 1 is 233%, which is actually net return. Gross return, if we turn it into percentage, what is that? 333%. Gross return, the difference between gross return and net return is 100%. Isn't it right? In other words, let's put it this way. Okay, here, where's that thing? Okay, canvas. New drawing. So suppose suppose you had principal of 1K, $1,000, right? You put it into the bank. Interest rate is 10%. You put it in the bank for 1 year. And 1 year later, that's future value 1. That means that's the future value at the end of year 1, right? You have 1.1K. Then, what is the return? Of course, anybody can tell the return is 10%, right? Because from 1K to 1.1K, right, the growth or the return is 10%. How did you arrive at that? Of course, you know, one period return is PT plus 1 minus PT, which is the capital gain, over PT, right? Or you can also call it FV over FB minus PV over FV meaning future value, PV meaning, you know, present value, right? But either way, no matter, you know, how you put it, for 1 year holding period, right? For 1 year holding period, your return is 10%. But this is net return. Of course, and also this is called capital gains. And so this 10% is net return, but but if you divide 1.1K by 1K, of course the ratio is 1.1. But this is, if we call this net return, this is gross return. And the difference between net return and gross return is 1 or 100%. Right? In other words, if you include the original value itself, then it is gross, right? And the original value itself is 1, right? So that brings us back to this. Think about it. This is 333% gross return, but if you subtract 1 from it, not 1%, but 1 is 100%, then the net return is this. Now, the gross return over the entire 11 years in scenario 2, it will be like 500%, right? Now, if I take the geometric average, right, I will have to, so I use, I did it this way. Anyway, J14 is what? This is the product of all of these annual growth rates, annual returns, and then I raise it to 1 over n minus 1. Okay, which is exactly, you might wonder, isn't that similar? This is exactly what instead of this being the ratio between, instead of this term being the ratio between the future value and the present value, this is the product of all the annual growth rates. So here's the idea behind it. This is the symbol for product. Sigma is the symbol for summation, right? Summing. This is Greek character pi, uppercase, product. Product of all 1 plus growth rates, individual growth rates, where I stands for individual, right? So for us, there are 11 data points, individual growth data points, right? And the I runs from 1 through n, so we have 11 of them. So if I do this for 11 terms, right, the result is this. But it will become simply 1 plus g raised to 11 raised to n if all the growth rates are the same. Of course, every year growth rates are not the same. It's uneven. But if we find an average will be, if I put average growth rate here, average return here, year after year, it's the same number. I mean, this result, let's say, so I have already found it, and we can do the, we can experiment. But if this G is average, if we found the average, then we don't need any time subscript anymore, because 2006 growth rate is the same thing as 2007 growth rate, which is the same thing as 2008 growth rate, which is the same thing as 2009 growth rate, and so on and on and on. Right? So the average can replace all the individual annual growth rates. Then it simply collapses to, it becomes 1 plus g raised to n. Right? So you understand what this, let me explain this. The product of all these 1 plus individual growth rates will simply collapse to 1 plus g raised to 11 if g1 equals gj equals g. Now for all I, this means for all I that is not equal to j. What does that mean? If I means individual time marker. So g growth rate in 2006 is, if 2006 is I, 2007 is j. And so gi and gj are two different numbers, right? Growth rate in 2006 and 2007 are different. And so I is not equal to j, and j is not equal to I is not equal to j, right? That's the reality. But if we find an average, then by replacing all of these by average, we arrive at the same product, right? By multiplying all of these terms, right, we arrive at this. But if all of these are, if all of the growth rates or returns are average, then all of these terms will be the same number, and then it will all collapse to 1 plus g raised to 11, right? And we still arrive at the same number, right? Same product. So this is basically, what it says. So then product of 1 plus gi raised to 1 over n minus 1 will give you, in other words, if we solve this equation backwards for g, in other words, if I solve from here to here this equation backwards for g, it will become like this. Okay, that's what I exactly did here, and therefore it comes to 16.34%. So suppose, let's do a little thought experiment. I don't need that actually. Let's do so that means if I do this, if I raise it to 11th power, will I get to this? Let's see. 1 plus this raised to 11. Yeah, I get the same number, right? If I round it to the third, decimal place, that's increasing, right? The same number. So that's what I used here. But here I'm going to use, so this is how you do it mathematically. But as someone said, I don't know, I couldn't see the list, but Excel has a built-in function called geomean. So that means geometric average, mean average, right? And then to use geomean command, I will have to use 1 plus r. Okay? then what do I get? Then, this will give you a gross return. So you'll have to subtract 1 from that. But, let's see, what does it give you? Why is it like this? Is gross return, so subtract 1 from it, net return, right? So this is how you find the geometric average under scenario 1 and under scenario 2. Even under scenario 1, using this geomean or this formula, you get the same result. I did exactly this here. Now, to some of you, this is like brain fryer. To some of you, oh, what is that? I can barely follow it. It's fine. At this point, you don't have to fully understand the process. The steps of derivation or mathematical, in other words, mathematical backing, mathematical reasoning behind it, at this point, fine, you don't have to worry about it. Later, there will be a time for that. There's a topic, separate topic for that. And so that is basically, so this is basically, the explanation that I gave you so far, basically. And if you got like, scared by this, no need to be. At this point, I'm just, you don't need to fully comprehend this. Doesn't matter. The reason I provided it here is, if you can understand, that's fine. That's good. Wonderful. If you can follow it, wonderful. If you can't follow it, that's still fine. But I cannot just throw the end result. Only the formula is basically the end result of the long process, isn't it right? The formula doesn't pop up from thin air. There's a long track behind it. The long track to lead, the long trail that leads to that end result. And there's a reason. I cannot just throw an end result at you, telling you this is the formula. But then again, this that is very. It's like showing you just the top of the building and not showing you the tip of the iceberg, and not showing you what is behind the surface, what is behind the water level, behind the water. That's what's behind the water, and from that you arrive at this result, which is simply the tip of the iceberg. But all you need at this point, all you need to use is the tip of the iceberg. But just later, when we get to the topic to understand the tip of the iceberg, the bottom part, the lower part of the iceberg, then this will come in handy. This will come in really handy. Or I don't know if I should call it handy, but there's a theoretical. This is this is the theoretical basis for that. Theoretical basis, okay, underpinning for that. Okay, so that brings us to the conclusion of the geometric average, right? So did everyone get the same result?
Yeah.
Good. That's very good, because
Yeah.
I didn't do this just to show you. I don't want you to just watch this and yeah, that must. I want you to get your hands dirty, or I don't know, get your hands into this, not just watching it, because watching it doesn't make you do it. It doesn't help you do it. I mean, it may help a little, but you have to actually do it at the same time with me. All right, that brings us to the conclusion of ROI. So we are moving on over to ROI and macro. Now, so it's already 7:30. So I think this is a good time to take a break. So let's take a 10-minute break. And when we come back, macro, ROI and macro. Okay. Oh, what happened? I hope, I guess I got logged out, but I hope this Blackboard Collaborate is still on. Alrighty, so let's take a 10-minute break. Let me stop sharing and mute.
Hello, Professor?
Yeah, we are on a break. Is it
No,
anything
quick
urgent?
question. I logged in. No, I just
Can
have a
you
quick
ask?
question. I logged in
Can you wait?
late.
Can you wait until? Can you wait until after we come back from the break? Okay, this is the only break I can
Okay,
have now. Okay, alrighty, all
okay,
right.
thank you. Yeah.
All right, we're back. We're back. So now we're moving on to the next. It's not a separate topic, but let's say the following topic or next topic. The next topic is interest rate. So come to think about it, we started out with the topic of ROI, return on investment, right? What is this? We started out with okay. We started out with ROI, which stands for return on investment, and so it is basically what we are after. I mean, the reason you are investing is to maximize. You want to maximize your return on investment while minimizing the risk, of course. But this will be another topic. But then, as we started out with ROI, Y is, so 8 holding period return, whatever. It's basically ROI. But why suddenly interest rate? But if you think about it, interest rate is also a kind of ROI. Interest rate is a kind of return. Isn't that right? Interest rate is also a kind of return. So what kind of return is that? It's the return on your money. And it is basically interest rate is the baseline. R stands for return. In general, rate of return. But in macroeconomics, there's a difference between R. I mean, I can stand for interest rate as well but obviously, why there's a difference between R and I. Because this is nominal. I usually stands for nominal interest rate. R usually stands for real return. And real return means what? It's the real interest rate. Real interest rate. Okay? So what is the real interest rate and what's the nominal interest rate? The difference between the two is the inflation. Okay? Now, but before talking about this, I said, so interest rate is the baseline, or in other words, lowest, or basic, very basic. Baseline return on money. ROI on money. That's return on investment. So I sounds return on investment, return on money. And I would interest rate is, if it is return on investment, it is really, really the lowest return on investment. Why? Because when we say investment means you are taking the risk, right? So there's a risk in every investment. Risk means, not only risk of losing money. I mean, it's called downside risk. If you lose your money, it's downside risk. I mean, I guess I mentioned, Google split on Monday. So I was very stupid because I guess on Monday I placed a buy order, limit order meaning, and limit order at 105 for 10 shares or something like that. That was on Monday. And of course, the price never went down to 105, but that order was still standing. I mean, it was 90-day. It has, like order duration or expiration was 90 days, so it was still standing. And today it was around 114, 115, and at some point early morning, around 10 a.m., 10:30, it even went down to like 112. And I also placed a limit order of 110. And I don't think it ever went down to 110, but I saw it was around 114, 112. So I placed, again, limit order to buy like 10 shares at 110. And every time I placed the order, it got rejected. Even if I placed the order, a market order, it got rejected. So I was wondering, why do they reject my order? I mean, it's not, and the price was even, at some point, it was even below my limit order. Why did they reject it? They should have. I realized that, there was already pre-existing order of 10 shares and 105, and I didn't have enough. I didn't have sufficient funds in my account to buy additional 10 shares. Because of that, I missed the chance to buy it at 112, but I still bought it at 114 or something like 114 something. But think about it. The reason I'm talking about this is when you buy something, when you buy Google or Amazon or whatever. Amazon split also in June, so and then it was around. I bought it around 110 or. Both Amazon and Google were trading around 2,400, 2,300 before split. They all had like 24-1 split. But after buying for 114 or 110, then there's a chance the price can go down. Even 1% probability, or even very small probability, it can still go down below 100, right? But it never happened. I mean, with Amazon, it didn't happen. It turned around after it hit something like, so it's called, resistance, support, or blah, blah, blah. But, that's all, in day trading, short-term, technical chart analysis terminology. But the point is, investing basically assumes that you are willing to take that risk of losing some money, or sometimes you can lose the entire position. I mean, I put $1,000 into this, you can totally lose $1,000, but still you are taking that risk. That hence return on investment, but interest rate is not return on investment, because if you put your money in the bank, what is the risk of losing that money? And the risk I'm talking about here is the downside risk. There's also upside risk, and upside risk is if the expected return is 10%, but actual return is 15%. That's called upside risk. And you could scratch your head. You will scratch. Why is it called risk? I mean, if the expected return was 10%, but actual return was 15, it's a good news. I mean, it's a pleasant surprise. I mean, it's a surprise, still a surprise, but a pleasant surprise. It's not a negative surprise, right? If the actual return was 5%, then obviously that is a bad news. That's a risk. But then that kind of risk is called downside risk. And the probability of the actual return to turn 15%, that's called upside risk. And why? Why is it called? So in a broad sense, risk means volatility. Risk means volatility. I mean, a stock return is volatile. Volatile means by definition, it has it's got a chance to go up as well, not just down. Down, if it goes down, it can go up. If it goes up, it can go down. It's volatility, right? It's volatile up and down. So risk involves basically not only downside risk, but also upside risk. And upside risk is, of course, pleasant surprise. It's not a bad news. If it is, but then there is nothing that has only upside risk, right? Isn't that right? If a stock swings, if the stock swings 20% up, then there's a chance it can also swing 20% down. And the wider this variance, the riskier it is, right? And the smaller the variance, the less risky it is. But then think about it. You put your money in the bank, what's the risk? What is there a volatility in the bank's interest that the bank pays? There's no volatility in the bank's interest rate. I mean, if you put your money in the CD, of course, savings account, you put your money in the savings account, they will pay you interest. Checking account doesn't pay interest. Although some checkings pay interest, but they pay you interest for using your money, isn't that right? When you put your money in the bank, you think you are saving with the bank, but if you think about it, you are passively becoming a lender to the bank, and the bank is passively becoming a borrower. It's not like the bank is begging you to lend them money. You voluntarily lended money to the bank, and passively, right, without thinking that you are lending to them. And with that money, what does the bank do? They will lend that money, right, to make money. So when you lend money, so the main business of the banking is in lending money, because by lending money, they collect interest, they make interest, they charge interest when they lend money, and then they receive interest. That's how they make money. So the main business of banking is in lending money. They make money by lending money, but they don't make money by taking the deposit. Of course, they use the deposit to lend, your deposit to lend money. But when they take deposit from you, they are obligated to pay you interest. Make sense? So that brings us to the distinction between lending rate and borrowing rate. Because when the bank lends money to you, I mean, you can do two things with the bank. You can save with the bank, then you are a lender to the bank. Passively, you become a lender. Passively, they become the borrower. On the other hand, you can also borrow from the bank. When you borrow from the bank, Yeah, you're actively borrowing, and they're actively lending. And then if you borrow $1 million from the bank, then money came from someone, some lender to the bank, some passive lender to the bank, right? And what is the risk here? I mean, if you put your money in the bank, you might want the bank can go bankrupt. I mean, will the bank always be there? Um, the bank can go bankrupt. There can be something called bank run, right? Because bank run is what happened, in 1929, when the Great Recession, the Great Recession, the outbreak of the Great Recession was, basically the stock market crash, 1926, I believe, stock market crash, uh, and then there was a bank run. Everybody ran to the bank to withdraw their money because the banks were all invested heavily in the stock market. And if the stock market loses, 100%, all the banks' money will be gone, and then that money is your money, right? Because your deposit in the bank was invested in the stock market. So everybody ran to the bank before their money evaporated. That's called bank run. Can that happen again? I mean, can the bank run happen again? A bank run itself can happen again, but most banks now are, after that, Great Depression, all the banks are basically, covered by FDIC. All the commercial banks, retail banks, right? Retail banks are covered by and FDIC is Federal Deposit Insurance Corporation. So it's the insurance policy for the bank deposit. And I don't think there's any commercial bank can do business without FDIC. It's just like, without your car insurance, you cannot be on the road, right? You get stopped by a cop and he asked for, obviously, if an officer stops you, he will ask for registration, license, and insurance. If any one of these you don't have, then you're in trouble, right? So just like that, no commercial bank can do business without FDIC insurance. So, but the FDIC insurance, is only covering up to $250,000. I believe it is per account. I mean, if you have $1 million and put it into the bank, if you put it into 4 different banks, 4 different accounts, I guess you'll be covered. So there's no risk of losing your money if you put your money in the bank. That's why I'm saying, interest rate is a kind of return. It's a return on. So it's a return, right, on your money, but riskless return on your money. Riskless, right? And all the return on investments have risks. Okay, and the savings account, of course, pays very, very mediocre interest rate. I mean, although the interest rate, baseline interest rate, or Fed funds rate, which is the short-term interest rate, Fed funds rate is now about 1.25, right? Because in previously was like for almost 10 years it was like 10 years since 2008, it was 0.25. Now, and it was, about 0.5 prior to June. And in June, FOMC meeting, they raised it by 0.75, so it is, now about 1.25. And in July meeting, which will be by next, I think July FOMC meeting is July 26th, 7th. I mean, what day is it? I mean, of course, it shouldn't be weekend. It cannot be weekend. So in about a week, in less than a week, we will know. And the market's expectation was, previously, 1% increase, but that expectation is now that expectation dwindled down a little. I mean, they are the most consensus is pretty much about 0.75. Another 0.75 will take it. So currently 1.25. So probably about 2%. But even when they raise the benchmark rate like that, your savings account won't go up that much. Now I'm going to explain why. But anyway, savings account really mediocre, right? CDs have been something like some CDs were paying one point something, 1.25 maybe, 1.5 if good. And the CD, certificate of deposit, is basically a savings contract, right? So bank interest rate is riskless, right? Riskless. And then there's a difference between lending rate and borrowing rate. And the name lending rate and borrowing rate is determined from the bank's perspective, banking industry's perspective. In other words, lending rate is when the bank is lending, right? So that's when you are borrowing from the bank. And borrowing rate is when the bank is borrowing from you. So that is the rate that you get when you deposit your money in the savings account, right? So this definition is from the bank's perspective, because the bank is the industry, not from your perspective, right? And the lending rate has to be greater than the borrowing rate. Now think about it. I told you the business of banking is in lending, right? Because they make money by lending money. So if they lend me $1 million, right? That $1 million came from someone. And then if they pay that someone, if they have to pay 5% to the someone who deposited $1 million, then when they lend it to me, they will have to charge me more than 5%, higher than 5%. Isn't it right? Otherwise, they cannot make money, right? If they charge me 5% and they pay 5% to the lender, then bank makes no money. I mean, they are just shuttling the money or funneling the money between that lender and the borrower, but they're not making any money. So lending rate has to be greater than the borrowing rate, and the difference is called the spread. Okay. And then there is a difference between nominal interest rate and real interest rate. And I told you, I is the symbol for nominal interest rate, R is the symbol for real interest rate or real return, pi is the symbol for inflation. Interesting thing is, symbols are not fixed. I mean, symbols, there's a consensus. I mean, there's a certain consensus, but symbols can be applied flexibly. So, for example, let me. So, nominal interest rate is real interest rate plus inflation. Pi is the symbol for inflation in macroeconomics, and pi is the symbol for profit in microeconomics, because pi is p in Greek, right? I think if you write in Greek, that looks like n. In Greek character, you would probably, this is how you write profit. Oh, but I don't know why pi is inflation in macroeconomics. I mean, somebody started using it like that in the past, so it just got settled that way. But if nominal, from this, we can derive, obviously, we can derive, I mean, if then real interest rate is basically nominal interest rate adjusted minus, that means adjusted for inflation. Okay, now we're going to talk about this later in depth, but for now, when we say interest rate, there isn't just single interest rate. I mean, single definition. There's a lending rate, there's a borrowing rate, and real interest rate, nominal interest rate, and then what else? And then simple interest rate and compound interest rate. And we already understand what compounding is, so I'm going to get to that later. But more relevant, I mean, at this point, before we think about this, what about the think about the borrowing, the lending rate. So the lending rate is when the bank is lending. So when we say when you say I put $10,000 in the bank, they are paying me 1% a year. I mean, these days, if they pay 1%, I guess that's quite decent these days. But there were in 1980s, 1985, around 1983, 4, 5, the bank interest rate was even something like 15%. That was a time, but so it doesn't matter. You put your money in the bank, or he puts his money in the bank, she puts her money in the bank. No matter who puts in the money bank, their money in the bank, whether they are college professors or CEO of a big shot Wall Street firm, or I mean, or whether it is just a plumber, or whether it is a bus driver, whoever puts their money in the bank, they all get something like 1%. There can be a slight difference, but something like 1%. But when they borrow, so lending rate, so what I'm talking about is when they lend to the bank, or when the bank is borrowing from them, I'm sorry, when the bank is borrowing from them, when the bank is putting the money, when they are putting money in the bank, this rate is just about just about 1%. But when the bank is lending, in other words, when they are borrowing, the rate varies a lot, from even 3%, the low 3%, to even 18% or 20%, right? huge variance in the lending rate. Why? When the bank is lending, what is the biggest concern? If you are lending money, what is your biggest concern? Anyone? I guess the
Risk of default.
yeah, the risk of default. And who was this?
DeAndre.
Speak up, please. Who was that?
DeAndre.
DeAndre. Okay, DeAndre. Yes, DeAndre. I'll give you 1 point. Yes, there is no denying it. Your biggest concern is the risk of default. In other words, is this guy going to pay me back, or is he, right? Is this borrower dependable? I mean, is it credit worthy, or I mean, is he safe borrower, right? In other words, is he gonna default or not? And that's called default risk, right? Default risk is the greatest concern if you are lending, right? And so, and how do you determine the default risk?
Oh, you could determine that by their credit rating.
Oh, yeah. Who was this? DeAndre. Okay, credit score, credit record. Yeah, I'm gonna give you 0.5 for that. Yes, credit record is the greatest. But before credit record, actually, they will look at credit score is something they use as a general criteria. But suppose you're actually borrowing money from the bank. Let's say you are buying a house, so you get a mortgage, and the house is like $1 million, and you get like $800,000 mortgage. That's a huge amount of money. $800,000 mortgage. Then before credit score, they will first thing they look at is whether you have an asset. Whether you have an asset that is above equal to the amount borrowed or 1.5 times that. 2, they look at your income, right? The higher the income, of course, the better chance of getting, and then look at the credit score. But but income and asset, it varies widely. I mean, so all these three factors, 3 elements are like 3 pillars, complementary. They're complementing each other. I mean, even if you don't have big asset and big income, great income or great assets, if your credit score is good, that kind of averages out to a positive side. Even if your credit score is not so good, if you have huge income and huge asset, right? They can they can collateralize. I mean, they can use it as collateral. I mean, they can say we can give you a loan, but we need a collateral. But if it is, look, if you're buying a house, the house already becomes a collateral, right? House already becomes a collateral. So that's the second range. But the thing is, credit score. Yeah, they look at the credit score to determine your default risk, right? So there are a couple of things that are related to. Okay, so so the lending rate varies. Lending rate varies widely depending on the borrower's credit score. So if you have a great credit score, wonderful credit score, excellent credit score, you won't pay more. Your interest rate won't be more than 3% above the Fed funds rate, right? That's called prime rate. Conventionally, the prime rate is about 3% above the Fed funds rates. And since Fed funds rate is now 1.25, 3% above it will be 4.25. That would be like, prime rate. If you have, a mediocre credit score, it will be probably 8% above it or 10% above it. And then the nominal rate and real interest rate, I'm going to get back to that later. Federal Reserve, basically, we all know FOMC, when they say June, there was FOMC meeting, Federal Open Market Committee. Federal Open Market Committee is what? That's where they discuss and decide whether to raise interest rate or not. But when they say they raise the interest rate, what interest rate are they talking about? They're talking about the federal funds market rate, Fed funds market rate. So I think we are already out of time. So we're gonna have to continue with this on Monday. Now, since I guess first topic is, okay, so this is not visible to you yet. There will be an announcement going out. I don't know if that announcement has gone out already, but there will be the first self-diagnostic test. Yeah, I think it went out already. So it's going to become visible 12 a.m. tomorrow. So please read this and follow the instruction. And I do my best always to. Blackboard is not such a perfect system. When I exit preview. When I made the exam and the assignment. So this is going to become, now it's grayed out, but it's going to become colored at 12 midnight tonight. This doesn't display mathematical equations correctly. So some of the mathematical equations are really, all messed up. So you need to also refer to this. It will become also available at the same time. Okay. All right. So that's all the time we had.